I met quite a few of you already. So my name's Dan, and this is what I do. I go around and train the linemen and introduce them to the RS product, to the RS pole. And you may hear through the grapevine that all linemen hate the composite poles. And what I've found with my experience, it's more that they hate the change. The change and the fact that we're going from something we're familiar with working with a wood pole, to something brand new. So how do we mitigate that? We try to make that change as gradual as possible, and there's two things they need to know. They want the knowledge and know-how, how to work with the new product, and they want the proper tools. So you give them those two simple things, and it makes that change process go a whole lot smoother, okay? So I'm just waiting for some of the volunteers to help me out. Here they come now. And I just want everyone to know the objective of this task. Come on in. Okay, these guys are replicating the linemen. So just so everyone knows, they're from the plant here in Houston, and they have not done this before. So this is brand new for them as well. And we were going to run a rehearsal run, and we didn't get around to it. Everyone's been so busy, and but we are going to do absolutely fine. We'll just take our time. We also have Van, the cameraman. He's going to obviously video record this. And I want to make it, as Rob mentioned this morning, very collaborative, okay? So raise your hand if you have a question. Hopefully you can still hear me okay. And we want to make sure we're answering your questions. So unlike the model pole, which we built yesterday, we kind of cut off a couple of half modules. These are full-length modules, okay? And the objective today is to assemble them and make them look more like a pole. And this is what we call the number 2 module and the number 3 module. We use the James Bond alphabet, so we use O, O2 and O3. So we have one smaller module, the O1, and we actually have a special standard module that's 1L. So if you're in a distribution area and require a little more length, you could opt for the 1L instead of the 1. It'll give you a 5-foot extra length, okay? And then so on and so forth. The O2, the O3, O4, O5. Now up to the O5, the modules are approximately 20 feet, 15 to 20 feet in length. And that's not counting the overlap area. And we'll talk a little more about that a little later. Beyond the 5, the modules are approximately 30 feet in length. So we doubled up in the naming. Even though it's one module, one section of pole, we call it a 6-7. So the 6-7 is one section, and then we have the 8-9 and the 10-11. If you stack all three of them up, they're 90 feet. So we're dealing with the smaller modules, the standard modules, and then we have a couple of non-standard. We have a 3L, 3 long, and we combined a couple of years ago the 5-6, okay? So if you look at our pole, I want to go over a few safety items with the crew here, first and foremost, okay? If you look at the pole, it looks kind of shiny and slick and slippery, and those of you who felt it, that's because it is shiny, slick, and slippery, okay? And we have to keep that in mind. You wouldn't want to step on this pole if it was on the ground laying in a ditch. A wood pole, you wouldn't think twice probably of stepping on it. The other thing is when we're handling this pole, because it's shiny and slippery, and because you can see there's pre-drilled holes, we have a tendency to get our fingers in there. We don't want to do that. It's creating what? Pinch point, bang on. So keep your fingers on the outside, and also because we are assembling these two sections, these two modules, we never want to get our hands in between the modules because you'll be working together as a unit, okay? So that's number one safety concern is the pinch points. The other one is PPE, okay? PPE is very standard that you would use on a wood pole. If you're doing a lot of drilling, we would recommend long sleeves. Most utilities, power linemen now have a standard that they require long sleeves. You would also require gloves and the normal protocol of a hard hat if you're in the field and safety boots as well. There is the option, if you wanted to wear a mask, you could. There's been numerous tests saying the dust is inert. It's a non-carcinogenic, but it can be an irritant over time. So that's an option as well. And those are your basic PPE. So everyone's equipped pretty good today. We're all set to go. Number 3, we mentioned it earlier. Scott said the poles are dielectric, and that's a bit of a trick statement. Even though the pole is very dielectric and won't conduct electricity, in the line world, the line trade, we cannot consider it dielectric. And that's because it may pick up contaminants during shipping, processing, laying in the ditch, and we don't test individual modules. We've collected a couple samples from the line. We've done that dielectric test on them, and they've surpassed the rating of a hot stick. So yeah, if they're perfectly clean, plucked right from the factory, they will be dielectric. But once they get to the field, once they are shipped, you cannot consider them dielectric from a lineman perspective. Therefore, you must use all your current work methods, working live line, and you would have to cover this pole just like you would any other pole with cover up and protect yourself in a live line environment. Having said that, it's nice knowing from a lineman perspective that this is not going to conduct electricity very well, right? So yeah, that's your basic safety rules. The next thing is handling. We always want to make sure during the training sessions, we always invite the stock keepers, truck drivers as part of the safety presentation, just to ensure they're using the proper protocol for laying the poles down, for transporting them. We like to have a little bit of space. Unlike a claw that'll grip into a wood pole, we always like to use a sling and get in underneath these poles. And anytime laying them on the ground, we also like to keep them off the ground, so it's easy for that next crew to get a hold of. Okay? So the first thing we look at are the properties of this pole. You can see they're slightly tapered, right from the tip to the base, and every module is like that. The other thing that we didn't show you is that the smaller module will fit inside the next larger module for every single module we have. And that's how you've heard many times today, that's in that nested configuration. You would have seen it out in the parking lot. So the lineman can easily carry and unnest this module and carry it here and prepare it for assembly. The other thing is, when you frame a wood pole, they have various names. They have front, back, gain, belly, and that's all trying to align the pole for their framing, because basically trying to get all the crooks and nannies and curves out of that wood pole to figure out the best way it's going to lay in the line. Our poles, man-made, are perfectly symmetrical, perfectly straight. So the language we use are axial lines, and we have 4 axial lines drawn from the factory on the pole. And we just labeled them with the alphabet. Okay, so we have the A, B, the C, and the D axes. And that's when you're looking from the tip, just like I am, down to the base. And that's how we communicate when we wish to frame this pole. And our main axis is the B. That's the one we want to face the sky during assembly. And that's the one that always has the pole identification tag on it. The pole ID tag has plenty of information on it. This one is a mock because of the demo. But if you're wondering about the pole, you come down here, it would tell you the total weight, it would tell you the length, it would tell you the distance this tag is placed from the butt. So there's no cheating. If you have a contractor or someone setting this pole in the ground, you can tell exactly the height and depth it's installed. Yes, go ahead, Rob.
So Dan, we all know these are lightweight. You mentioned they have the weight on there. What are the weights of these 2 modules?
Good question. So this one here, if I can read upside down, I believe weighs 161 pounds, this entire module. And this one here is 2 something, I believe, 210. And if you guys want, just like I showed you earlier, perhaps get the 4 slings and just do a basket carry. Just move it out that way, move it back. Okay, with the slings. I'll get out of your way. And while they're preparing to do that, the pole ID tag has the information for the entire pole, but each module also has a serial number. serial number tag on it as well. Yeah, go ahead. Yeah, and I was hoping to show that. So nesting is when this module is inside of this one. So basically when this module is inside of this one, it's called nested, and there's only one bolt that holds it together, and it's called the shipping bolt, rightly so, right? And it's always installed on the D axis, and it's where the modules are compressed. So anytime in transportation, you want to make sure that D axis is pointing towards the ground. Okay, and to undo it, it can be difficult because it's meant for lasting all the bumpy roads during shipping, and it has a nylon lock thread on it for the nylon nut. So it takes 2 adjustables or an impact gun, and you undo it, and once that bolt is done, you can carry these sections and line them up just like they are now. Okay, yeah. Oh yeah? No more nylon? Okay, good. We had a few sticking on us, right? So, very good. All right, so these gents are just going to demonstrate how we did earlier, how to carry them. Just watch your steps, plan your route, go in the same direction. All right, I'll pull this out and go that way back, and we'll just put it inside this one. Yeah, go ahead. No, you're good. Don't move. Just don't move now. Yeah. And let's just put it up and right inside this one. Watch your fingers. And you can just slowly move back and carry it forward. Very good. So basically, you could have, this could be the length of your 75-foot pole using our smaller modules with them fitting inside the other one. And I'll also mention during this nested portion, it's the first decision the supervisor has to make, because there's areas where you want to unload and assemble the pole in the field, but there's also areas where you want to do it in the yard, where you're in a controlled atmosphere, there's no traffic concern, and you just trailer it out like you would a regular wood pole. However, there are circumstances in the field where it's much more advantageous to take it out nested. Perhaps it's difficult to get to. You could take an excavator and literally crawl this out of into an off-road right-of-way and assemble it at the site. So it's one of the first decisions the supervisor has to make, and it's that's part of the training. You wouldn't want to assemble this on the side of a busy roadway, right? It'd be much easier to assemble it in the yard and then trailer it out like a normal pole. And I should also mention, many utilities have the poles already assembled. They can do it at the factory here as well. So that's a choice of the utility as well.
And
so,
if I could mention,
yeah.
in the distribution case, about 90+% of our customers receive their poles already assembled from our plant. It's the cases like Dan mentioned. If the operational conditions in the field dictate, or if it's a backyard, they come nested. Transmission is slightly different dependent on the
Yeah.
project.
And 90% of that's maybe a little skewed because most of it is center point, right? A lot of our poles are going to center point, which are assembled. But where I come from, Hydro One, they also are at the point of the poles are already assembled. So it is circumstantial. All right, any more questions on the nested? Oh, very good. All right, gents, let's repeat that. We'll take it right back down. So I'm going to show you the slick way of doing this. So you guys just lay off a little bit. You guys will take the weight and back up, facing that direction. So this is how you carry them by hand. Grab a low grip here and back up. You guys wait. Take it out, take it out, take it out. Just go nice and slow, easy. So if this was a truck, we've rolled it out by hand, but if this was a larger module, you would do this with a truck boom, and as soon as you see that center of gravity line, you would reposition the sling over the center of gravity line. And once it's at that location, it's perfectly balanced. One person could easily maneuver it while the boom truck operated it. So this one will keep going, and we just want to make sure it doesn't pop out on you. So when it's about 2 feet left in there, you guys let them know, and you can take over your portion of the weight, okay? Make sense? A little more. Good communication is key. You always want to clear the path and work in unison. And if that was a little heavy for 4 workers, you can also put 2 workers in the middle. When you lay them out, you only require a couple of feet. There's no magic distance here. But if we were assembling this pole in the field, just like a wood pole, the base would typically go close to the hole in the ground, the location of installation. And as the workers are putting the pole in place, you're always thinking of that B axis and pointing it towards the sky. Okay? Okay, so the next step, I just want to point out the tools that are required for assembly. Now, I don't know how well you can see, there's 2 lever hoists here on the ground. They are very specific. For the compression forces, we require between 6,000 and 8,000 pounds of compression force. That's a lot. That's a lot of compression. So that equates to 2 1.5 ton hoists or 2 2-ton hoists. I would not recommend going to a 3-ton hoist. A 3-ton hoist is very common on transmission crews. You may risk ripping the jacking hole. So if you don't have a 2-ton hoist, which is very quite uncommon, 1.5 tons is the choice to go to. A little bit smaller, and you have that little leeway there. Most line crews do not have a dynamometer on them to measure that 6,000 to 8,000 pounds, and we don't recommend it. If you're really questioning some of your assemblies, you could have one, but it's an unnecessary tool. So the lever hoists themselves are a very common tool on any line truck in North America. All right. What's the RS specific tool that's required are the jacking bars. Because of the heavy forces, it's a specialized bar. I'm not sure the material, Sean. Do you know what they're made out of these days, our jacking bar? Just pure stainless? So yeah, I thought there was another alloy. Regardless, they will last for hundreds of compressions, 1 set of bars. And the key with them, you'll see when the workers put them in the assembly, is to get them as tight to the pole wall as possible, because we don't want to bend them during the jacking process. So that's what we're going to do now. But those are the main tools that are required. Some other ones are the dead blow mallet and then some specialized hardware on the pole. So gents, I know a few of you practiced, just put the jacking bars in. And from the factory you can see there are pre-drilled jacking holes, and they are just a little bit larger than the bar. They're 1 1/16 inch. The bar itself is 1 inch. And let's just slide this pole stand back, guys. So lift on that end, and we'll just get it out of our way a little bit.
Push it that way?
This way, yeah. Very good. That'll just let you maneuver that a little easier. Yeah, no, the plate first. So the jacking bar itself is the kit. It's a special RS tool. It literally comes in a gun case in behind here. And that's just kind of saying, guys, let's kind of look after this tool, and it'll last for many, many installations. So as tight as possible, rotate that. And there's just a set pin in there. Going back 5, 6 years, we did have a different type of tool, jacking lug, which required a chain to go around the pole. And it was easy to omit that in the field. And because of safety, we didn't have an incident. I think we had 1 incident at the factory. We went directly to the bar, and now they're perfectly safe. That cannot happen. And because of the numerous holes in the bar, you can see this one will accommodate right up to our 05 modules. For our very large modules, we have another longer set. Very good, gents. Okay, it's all learning from here. So I'm going to talk a little bit about the joint. The slip joint overlap area is literally the amount of overlap this module goes on to this one. And this varies depending on which modules you are using. Our large modules, it can be almost 7 feet of slip joint overlap. These smaller ones, you can see it's 2.5 feet or so. A rule of thumb is it's 2.5 times the diameter of the module you're using. And the spanning distance of the jacking bars also affects, if it's a larger modules, they'll be further apart. So if your lever hoists don't span that distance, you can just add slings and make sure you can span. It's up to 12 feet with our larger modules. Now you'll see a lot of line crews, if you've noticed this before, they'll try to handle this and put it on this module before you put the jacking bars on. And you could do that, but what the jacking bars do now is give the workers a hand held, and it allows them to manipulate this module onto this one. So gents, just let's lift this one up and move this pole stand back. Just to back this way, a little bit, other way. Good, very good. I'm going to talk a little bit about our pole stands because they're relatively new and you think they were made for the RS pole. We'll take credit. But they actually come from the oil pipeline industry. We buy them right from Proline. And you can see they have a concave surface. And they make the ergonomics of working with the pole very friendly, right? If you had to frame this pole, rotate it, they're very slick. They have a working load limit of 12,000 pounds. So you could use them on any pole type. They're stackable and they're relatively light. They weigh approximately 40 pounds each. Now, the thing when you're putting them together, which is our next step, any questions? I know I'm rolling right along here. Any questions so far? So when we're putting it together, we don't want the poles to bind. And you can do this as long as it's fairly straight. You could do it on a hillside. It doesn't have to be perfectly level, but the key to watch out for is we don't want the poles binding against one another. So we're just going to keep an eye, and I'm going to have 2 of you, one on each side of this pole jacking bar here. Just maneuver onto this module here. And it wouldn't matter, we can maneuver this one onto there or vice versa. Usually with this being the heavier module, it's the one that's stationary, okay? And you guys are just gonna, what you want to do as you're maneuvering it is you want to keep these axes lined up here, okay? Sure. And it'll start to stick. You can see with the fine ridges of the strand, the fiberglass strand, ridges here, even though it's really smooth, but they begin to build up friction, even doing it by hand. So the key here is to really take your time, because even if you jam it on there quickly, it's difficult to get back off. So just take your time, gents, and you can help them with the communication. Don't get your fingers in between, okay? And we'll just move this module, okay? And if it interferes with the pole stand, we'll kick that pole stand out. Yep, doing good. Down a little bit. So you guys want to lift this one up then. This one's a little higher. There we go. There we go. No, doing good. Doing good. And you can see it overlaps quite a bit just by hand. And that's the idea. Our axial lines are bang on, and you're good. You can stop right there. Now, a key point here, and this was a good example. Right from the factory, there's a target assembly line that's printed on every module. Okay? If the line crew was not trained, they would think target assembly line, that's where we got to go, right? It's just a guideline, really. The number one criteria is to max out our hoist. Many times we reach that target assembly line almost by hand or just with a couple of 100 pounds of compression. So that's why we can't really go by it. It's a guideline only, and you'll see the process here. Many times we'll go past it, and sometimes we won't reach it at all. But if we don't reach it after maxing out our hoist, we don't get larger hoists. That's a no-no, okay? And 90%, our tests have shown 90% of the time you're within 1 inch of the target assembly line. You could be past it, you could be before it. But that means the other 10, 15%, you might be 2-3 inches away. And that's still okay, okay? So the other thing I'll mention here is you say, why do you have to have the axial line lined up? The true answer, you don't. We could have that totally off. The pole is perfectly symmetrical It's not oval, it's perfectly circle, it's round. And the only reason we keep this axial line lined up is for your framing, right? We just get in the habit of keeping it in line. The pole ID tag is usually going to face your roadway or the tangent down line, and that's up to the utility as well. And otherwise, this is just to make sure we're putting our insulators, transformers, whatever is going on later, everything will be in line. Okay. Any questions on that? We're going to get right into the working portion here soon. Okay guys, let's operate these hoists. We'll put them on to span the gap. So this will take the head of the hoist here, this hook here, and put it right in there. And you guys can do the same and mirror image on the other side. We'll have 2 on each side. You'll see there's an up and down, these levers here, and you'll want it in the neutral position or down to get your chain length out, okay? And I'll let you fight with those for a minute. So this one, sir, this one will go on this side of the pole. Yeah, very good. And this is the tail of your hoist right here, and you're gonna put it in that. We're going to span, yep, just like that. If these chain hoists were not long enough and you had to use slings, you would want to use clevises with the slings because you can see the plate on the jacking bar is fairly sharp, so you'd want to be safe. Now the idea with the 2 hoists is when you start jacking them together is to do it simultaneously. And that's easier said because if you watch, sometimes the one pair of workers, they're all set to go and they'll start jacking. The other guys are still working on their hoists and they're not synchronized. So really you're only getting half of the compression if you're not doing it simultaneously. Okay, so let's, there's a little lever here.
Okay, I'll put it on down position.
Yeah, and sometimes you just have to turn this or put it in the neutral position, okay? That's okay. These are brand new hoists too, and sometimes they don't cooperate. Is that the up or down? That's up, I think.
That's down.
So you might have to just lever that out a little bit. I think it's starting to go now. No. Did this one go okay?
Yeah, this one went okay.
This one's all set?
Not a
Okay.
problem.
All right. Let's try the neutral position. Try loosening that clutch as well. Sometimes it's still going in the opposite direction, isn't it? Sometimes with line equipment, it's the old adage, the rougher you treat it, the better it works. Yeah, just pull when you're in, pull. There, that's starting to go. You're gonna have to do it by hand. Yeah. There you go, there you go, there you go, there you go. Good job. And now when you switch the lever in the up position on both sides, and we'll just take them up so they just begin taking up the tension. Okay, don't worry about, just start cranking them. Yep. Make sure it's in the up position, the lever. And sometimes you can turn this as well to get it working. I'll let you do it. Go ahead. Okay, gents, so good spot here. So you have some slight tension. The thing you have to watch for at this stage is these plates. Make sure they're up parallel with the pole wall. See how that one's down a little bit? Up nice and parallel. See how that one's down?
Hold down, up, down.
There you go. And just start using the handle on the hoist. There you go. Okay, just stop right there. So now we're just starting to put tension on the hoist. And these are nice and parallel. Sometimes they'll catch, which is good. And now simultaneously, you can see just that slight amount of pressure. We've hardly touched it. We've already reached this target assembly line. So if you weren't trained, typically you would stop there. We don't want to do that. We want to max out the hoist. All right, good gents. Go ahead. When that starts getting extremely difficult, you can see it chugging. Okay, stop. Once they're getting close to maximizing, they stand away. A little unorthodox. Stand back a little bit. Okay. And there's pent up friction in here from cranking those hoists. And we release that by whacking it with the dead blow mallet. And the pole is tough. You're not going to hurt it with this dead blow mallet. And many times when you do that, it releases that energy, releases that friction. And what that does is shutters together. It puts slack back in the hoist. When that happens, we repeat the process. Typically after you do it twice, it won't move anymore. You hit it, it will not move. And that's your joint. That's it. As simple as that. So back out and just hit it. And sometimes you won't see it, but we'll just try again, see if there's any slack. Back away again. I'm going to hit it again. I don't think it moved. You can try again. Done. Okay, you maxed out the hoist, hit it a couple times. It's gone beyond the target assembly line. That joint is complete. We can take all this stuff off. Yeah, go ahead and take it all off. And that typically, yeah, neutral or down. Actually, the down lever. Yeah, there you go. And crank. You have to crank it a couple times. Yeah, get some slack into it, and then we're done. So another complaint sometimes you'll hear is, oh, it takes too long to assemble the poles. I've had a crew once assemble a 4-section pole in 16 minutes. And yeah, they were gung-ho. Typically it takes a couple of guys that can move on to the next joint. And really, when they get the flow down with all the other things that are going around the line truck and crew, and they get familiar with it, it's not an obstacle whatsoever. Okay? Take those off. We're all done with all of that. Yep. Now this 30-foot pole, it's acting as one now. It's one linear section. And if we had to add another section, we would just repeat the process. A little bit about the slip joint. We don't know exactly how far up here it is. I'd say approximately here. We do have a couple of drilling rules, and I'll identify them now. Because our pole is hollow, there are a few rules to abide by to ensure it has its maximum strength. The one is the 6D rule. D stands for diameter. For easy math, if this was a 1-inch hole, the next closest 1-inch hole, we would want to be 6 times D or 6 times 1 or 6 inches away in any direction. So that's pretty lenient. I mean, you could have holes all over the place and you're still within the rules of the pole strength and its ability. And typically a 1-inch hole is a very large hole. It's usually reserved for pole steps. For a 3/4-inch bolt, we'd recommend a 13/16 hole. And that brings me to the second rule. You wouldn't want to put a 1/2-inch bolt in that hole. Because the pole gets its strength from the surface area and that small 1/2-inch edge, you want to try to match the bolt size with your hole size. So a rule of thumb is a 1/16 inch larger hole than your bolt. So if you have a 5/8 bolt, 11/16 inch hole. 3/4-inch bolt, 13/16 hole. That's rule number 2. Number 3 is the slip joint no drill zone. Because this pole in heavy winds, hurricane winds, we want to preserve this joint area. And we don't want any holes drilled within an 8-inch range. Not to be confused with this, we can put holes up here, but we don't want to drill any holes 5 inches above this slip joint edge and 3 inches below. That gives us a total of 8 inches. My guys used to break this rule all the time. The pole's not going to implode or blow up, but just to maximize its strength, it's good to be familiar with that rule. The final no drill zone is an area at the butt or base of the pole, specifically above ground level. So if this pole, 30 feet we'll say, typical embedment is 10% plus 2 feet, or whatever your standard calls for. It can be different in rock, it can be different in swamp. But with our full-scale tester that you learned about this morning, we're finding that 90% of our poles or more, when they break what, 2 to 4 feet above ground level. So that's also an area we want to preserve, and if possible, not have any holes here. And we just changed that rule. I believe it's 36 inches now. It used to be 7 feet or 8 feet, and now it's just 36 inches above ground level. And I asked Sean this question once. The maximum hole diameter is 1 1/4 inch. And the idea is we don't want big portholes just above ground level, right? So we have to have a few little drilling rules to keep things contained. And that's about it for the drilling. Yeah, go ahead.
How do you attach the pole grounds in that area then?
Very good question. So the question is, how do you attach the pole ground? Just, yeah, if you want to dig those out. Yeah, and I have a bit of a display after. You can look over on the table. And I get asked this question. They ask, can I use a staple on this pole? And I giggle a little bit because this is extremely tough material. You're going to take someone's eye out if you try putting a staple through there. Staples do not work, won't even come close to penetrating this. I can take a sharp knife and it'll barely make a mark on this pole. In the wood pole world, you actually frame the pole, you go up the wood pole and you make your marks with a knife. Okay, we use a Sharpie marker, works splendidly with our pole. So to answer your question, we basically use a self-drilling screw. It's the same as a roofing screw, steel roofing, exact same. And the thing to keep attention here, pay attention to, is the length. It's 1.5 inches minimum. And the idea is here, because the pole is so tough, we want to make sure that drill point penetrates the entire wall before the threads start biting in. And then we don't want to over torque it either, right?
Does that count in your 3-foot no drill zone?
It counts within itself, but it's such a small diameter, you rarely would have to worry about it. So also on grounding, I'm glad you mentioned it, you have the option of putting your ground wire inside the pole and protecting it, or leaving it on the surface. And we have a number of different clips to accommodate your number 4, number 2, number 6 ground wire, whatever the size may be. Okay. Okay, guys, where was I? Back to the slip joint. So the no drill zone here is the 8-inch range, but don't get confused with the actual slip joint area. You can put holes out here as well, no problem. I'll also mention that at this time, because these modules were pre-drilled at the factory, the factory can also pre-drill for your pole steps. So people think, oh, you can't climb these poles. Well, you can climb them. You just can't use your spurs. So you have to use pole steps. I'll show you one a little later. And we can, as long as you're abiding by that 6D rule, we have some standards on the distance and spatial orientation of your steps. But you can easily accommodate climbing and have more steps around a transformer to have full lateral rotation around that pole to do your work. Now our jacking holes, where'd they go? Right here. Typically these holes would have steps in them. One of the other little rules is we don't want to leave any unattended hole without a plug in it. And you never want to install the plugs until the pole's at its final destination. You can see they're tapered, so we don't want to be transporting the pole with the plugs in them. And that's just to keep the bees and hornets and wasps away from nesting inside the pole for that next crew. So we simply just plug the pole. We can hit it with that dead blow mallet. And there's, I always recommend the crews having extra hole plugs. Just give it a couple taps on both sides. Now, gents, one thing, oh, you do have the drill there, so we're going to have to do some drilling here.
Yeah, we brought it through.
Okay, excellent. So we'll try drilling right here. So the final stage of the slip joint assembly, especially if the crew didn't have training, you could lift this pole up because it's properly assembled by its tip, and it would carry the full load of the pole, the full weight of the pole, no problem. But we want to guarantee the joint. And we do that. If this pole was going to be installed by a helicopter, perhaps the crew, they stopped at that target assembly line and really there was hardly any compression on it, so it has a chance of slipping apart. We always want to guarantee it by putting in our blind nut bolts. You hand me those little bolts. Perfect. And we'll need the drill. So this is a bolt that goes in the A and C axes, and we have to chase drill it because we're not sure how far up it's going to be. And it's just a nut and bolt configuration. Once we drill the hole, we slip the rectangular nut inside. We make sure we hang on to this retention wire. We pull up or down on it, and we proceed to install the rest of the bolt. So if you want to come around with the drill, come around to this side. And we're going to proceed to do that right now. Now normally there's a slot here. You can see it down here. So right here, right inside that hole. Yeah, a bit of an angle to start. Very good. Now, having the proper tools, as mentioned at the start, is key. That was slick, right? Cut through there like butter. That's because he's using the proper carbide tip hole saw made right here in the US by MK Morse. But that's the best hole saw bit we've found so far. And any hole over 1 inch, that's what we use. If it's less than a 1 inch, where's the other auger bit, gents? I just had it here. If the hole is less than 1 inch, Milwaukee just came out with this bit a couple of years ago, and it's very slick as well. This one's a little, requires a little more torque, a little more power, but it's fail-proof. I mean, there's only one piece, very solid. I'm trying to get Milwaukee to make a bit that'll accommodate our 1 1/8 inch hole as well. So right now we have 2 bits, the Milwaukee auger bit and the MK Morse hole saw. We got the hole in there? Yeah, I'll let you do it. Go around the other side. Go around that side if you want. And you guys have done this, right? Oh, this is old hat. Excellent. So we can repeat it on this side. This is, make sure the cameraman can see you there. Yep, go ahead. Don't let go of that. And pull one side or the other. Pull that right down to the pole wall. Yep. And what you do is you just hand tighten it and 1.5 to 2 turns. And this is also where I mentioned for any of our hardware bolts, including this blind nut bolt assembly, the recommended torque is only 50 foot-pounds. And that's almost nothing. Some of the big guys in here could do that by hand. It's literally 1 or 2 turns with your crescent wrench. You'll notice on wood poles they're just cranking down sometimes 800 foot-pounds of torque. That is not required on any of our bolts. Our poles will not shrink or expand over temperature, over time, over humidity conditions. That makes it very attractive for line crews to install gang-operated switches or anything that has a lot of moving parts. Once you tighten it once, it's going to stay nice and tight. Excellent. There, I do have a wrench over there if you want to tighten that up. And we'll repeat the same on this side. Yeah, I can hang on to that. Go ahead. Good job. That module section is now guaranteed with bolts. It is not coming apart. If for some instance you require to get this joint apart, there was lots of talk this morning, perhaps this module gets damaged by a vehicle strike. As long as you have a couple of feet, 2 or 3 feet of good pole up here, which typically you do, you can use our special disassembly tool, and it's actually right around the corner if you want to see it later. It comes in 2 larger cases. It's a special tool manufactured for the disassembly of the RS pole. And it comes with 2 10-ton bottle jacks. That's the amount of compression you have to get this thing apart. But there's 2 ways. You could, if this pole was damaged in the field by a vehicle, you could install the exact same pole right beside it and pull this one out, bring it back to the yard. Maybe you get 2 or 3 built up, and then you could disassemble it, get rid of this piece, put it into the landfill, and reuse these upper portions. And where I come from, we've been installing these poles in Canada since just 2005, my utility 2010. If that pole was installed in 2010 and got hit by a vehicle today, I could take the exact same module and replace it. This pole upper portion would be 16 years old, and it would still be the exact same fit and compression. So very interesting that the specs have not changed over time. So that's guaranteed. You could literally, a helicopter installation, you could grab this pole with a bolt through the upper portion, and it would carry the entire weight. And that could be for a 90-foot pole. And it would carry the entire weight of the pole. The only other couple of things is the top cap. So if you just want to pass me the larger one first. Typically when you have the pole together, the next segment is framing the pole. So a couple rules there. You always want to measure from the top or one of the joints. It's going to give you complete accuracy. And the old adage with carpentry is very much relevant with this. Measure twice and drill once. And we don't have quite the leniency, so we always want to be very accurate with our measuring. And we always drill from the front side. So rather than using a long through bolt, we prefer to measure, drill from this front side, turn the pole over 180 degrees and proceed to drill the other side. And that gives us pristine accuracy for the through bolts. Okay? And it's only after we have the pole drilled and framed where we proceed to install the top cap. Now the factory will cut the pole to whatever length you require. So because of that, the top caps come in 1/2-inch increments. As you can see, the diameter of the pole here is going to be a little greater than if it was cut 2 feet higher. So we're not perfect with these, but these come in 1/2-inch increments. And with when you order the pole, it will come with the accurate one. You can see this one's a little bit big, so we'll use a smaller one. And it fits perfectly, this one, right? Like it was meant to be. The top cap is installed with the exact same screw as the grounding screw, only because we lost a couple of top caps in the last couple of hurricanes, we've added this integrated washer just to spread out the load on the top cap, to spread the load out and hopefully keep them on the pole. I don't think we grabbed a base plate, but typically you would always install the base plate. Unless the pole was going in pure rock, you would make sure that there was the base plate installed as well. And the newest one we just designed a couple of years ago, a year and a half ago, it also is installed with the same 5/16 self-driven screw. So very handy, streamlining what tools are required. And embedment, there's a lot of options for embedment. Our literature requires or says 3/4 inch minus gravel, but you can use pole foam is very common. Concrete, even native soil. It's almost easier to remember what not to install. We don't want any jagged rocks or up against the pole edge. Other than that, very lenient. You can put them in pole cribs. Rock anchors have been tested and they've surpassed the tests of using a rock anchor as well. Where I'm from, we have rock and swamp and everything in between. So the poles won't crack with the cold weather, and water won't bother them either, seeping in or out of it. Any other questions? So this pole is, once it was framed, it'd be ready to go on the ground. Yeah. All right, well, I'll be hanging around here a little while. If you have any more questions, please come on up, get a feel for it if you want, but that'll be it for the physical work. Thank you, gents, very much. You did a great job. Yeah.